Good morning, students. Here I am today. I want to talk to you a little bit about the life cycle of a star. There were quite a few students that were a little bit confused even after watching the video. So I just thought I would do a short video or a series of videos to explain the life cycle of a star. Okay. And really, the life cycle of a star depends on how big the star was when it formed. So stars that are smaller are called low mass stars. These are stars like our sun. Okay, so our sun is considered a low mass star. Um, so anything that would be significantly bigger than that would be a high mass star. Okay, we will first start with the life cycle of a low mass star, and then we will do a high mass star in a different video. Okay, so our sun is a low mass star. Okay, and there are some questions coming, so please make sure you're paying attention. Our star is a low mass star, and if you look here, I can actually put this on Google Classroom, the link to this PDF. Right now, our sun is in its main sequence. Okay? This is when it is converting hydrogen to helium. So the only fusion that's happening in a main sequence star, like our sun, is from hydrogen to helium. And even remember when we talked about nuclear fusion, that was the main nuclear fusion we talked about, was hydrogen to helium. Okay, so that's main sequence. And the sun will spend 90% of its life doing this. 90% of its life, it'll be main sequence, it'll look just like this, and it will be converting hydrogen to helium. Now, inside of our star, there are some forces that are acting on it, keeping it steady. Okay? You have nuclear fusion happening in the middle, pushing outwards. Okay? Nuclear fusion is pushing outwards. And you would think if you have all this force pushing outwards, maybe our sun would get bigger and bigger and bigger and bigger. But it doesn't. Why do you think it doesn't get bigger and bigger and bigger and bigger when you have this nuclear fusion pushing it out? Okay? It doesn't get bigger because gravity is holding it in. Okay. So our star is a balance. It's at a balance between nuclear fusion trying to push it out, make it expand, and gravity trying to crush it in on itself. Okay? Stop for a moment. I want you to make a prediction. If you get the questions wrong in this video, by the way, it's okay. I want you to make a prediction. What do you think would happen if nuclear fusion stopped and we didn't have this outward force? Answer no. What do you think would happen if there was no gravity and we only had nuclear fusion? What would happen? Okay, great. So what happens why does a sun become a red giant? Why does a star become a red giant? When it runs out of hydrogen, it starts to turn helium into oxygen and carbon. Okay, so let's just write some of this stuff down, actually. So what are the notes about main sequence stars? In a main sequence star, these can be your notes, okay? What are the main ideas that you need to know about in a main sequence? And we are talking about low mass stars right now, like our sun. I'm just gonna make this whole thing. Low mass stars, main sequence. Okay, what do we need to know? We need to know that hydrogen is being fused into helium. Okay, and the star has balanced forces. Well, okay, we'll just say balanced forces between